Here, we want to use our financial calculator to compute x bar, that is the mean of x, y bar, standard deviation of x, to be more specific, sample standard deviation of x, sample standard deviation of y, population standard deviation of x, population standard deviation of y, and correlation. So let's get started. We would press second function, then data. This is second function here, and we have data because data is a secondary function, so we need to press second function. To better make this easy for us, let us name this x01, this is y01, x02, y02, x03, y03. So we will press 10, which is x01, then enter. Enter is here. Then arrow down, this is arrow down. You press 10 again. The 10 is coming from here. Then you press enter. Then arrow down again. You press arrow down, and that will show x02. So you press 15. Then enter. Please do not forget enter. You press arrow down again. That's this. Then you press 20. That's y02. Then enter. Arrow down. Then you press 20. Then enter. Arrow down. You press 30. Then enter. So now we are done with imputing the data. The next step is now to press second function start. So this is second function, then start is here. Start is a secondary function. What I expect you would see on the face of your financial calculator is lin, L-I-N. If you do not see lin on the face of your calculator, then you need to press second function set repeatedly. So you press second function set until you see lin on the face of your calculator. Please, lin is not the same thing as ln. Ln is natural logarithm. This is linear. This is what you need to see on the face of your financial calculator. So once you have this, then you can press arrow down, and it will show you n is equals to 3 because there are 3 pairs. And this is also another way to know that you have made a mistake. If you see this as 2, that implies that probably you failed to press enter on either of these. So you keep pressing arrow down. I have everything summarized here, your x bar, your y bar, and so on and so forth. But it is worth noting that your financial calculator cannot compute variance. So to compute variance, you will have to square your standard deviation. So if you're interested in sample variance of x, you would square this. If you're interested in population variance of x, then you will have to square this. It's also worth noting that your financial calculator cannot compute covariance. So to compute covariance, you use the logic we discussed from the previous slide. Covariance of x against y is unstandardized. As we said on the previous slide, the correlation of x against y is standardized. So if that is the case, that will help you recall the formula. The correlation of x against y is equals to covariance of x against y all over standard deviation of x times standard deviation of y. This is unstandardized. Covariance is unstandardized. Is unstandardized as said on the previous slide because it ranges from negative infinity to positive infinity. That is, it could assume any number. Unlike correlation that is standardized, correlation ranges from -1 to +1. So to standardize this unstandardized covariance, you simply divide by standard deviation. That's standard deviation of x and standard deviation of y. So this would make life easy for you. So now, if you are interested in the covariance of x against y, it will be the correlation, which your calculator will have computed for you, times the standard deviation of x, which your calculator will have computed for you, and the standard deviation of y, which your calculator will have computed for you. So what you just need to do is to multiply all of these across board to get your covariance. Here, we are interested in computing the standard deviation of x and y, both sample standard deviation and population standard deviation, the mean of x and y. We are interested in computing the correlation between x and y. So let's get started. Second function, data, x01 is 10, so I will have to press 10, that's 1, 0, then enter, arrow down, y01 is 10, so I will have to press 10, then enter, then arrow down, x02 is 15, from what I have on this table, then enter, arrow down, y02 is 20, then enter, arrow down, x03 is 20, enter, then arrow down, y03 is 30, then enter. So we are done with imputing the data. So the next step is to compute the mean, standard deviation, etc. So we need to press second function start. So we have LIN, linear, on the face of our financial calculator. This is what we need, but let us assume that we have something else outside this LIN. How do you navigate to LIN? To navigate to LIN, you press second function set. You press it repeatedly, second function set, second function set, second function set, second function set. Now I'm back to LIN. On the exam day, if you have LIN on the face of your financial calculator, then you are good to go. You do not have to press second function set repeatedly. So the next step is to press arrow down. So we have our n, which is equal to 3, the mean of x. I have it here. The standard deviation of x, to be more specific, sample standard deviation, that's 5. Arrow down, the population standard deviation, we have it here, of x. The mean of y, that's 20, we have it here. The sample standard deviation of y, we have it here. The population standard deviation of y, we have it here. Still pressing arrow down. If you're interested in forming a regression equation between x and y, you have your intercept already. Your intercept is negative 10. If you're interested in the slope or the regression slope or the regression coefficient, we have it here. If you're interested in the correlation between x and y, it is 1. That's +1 to be more specific. So you can keep going on and on and on. If you're interested in the summation of x squared, that is, after computing your x squared for each of the variables, if you sum them together, that's relating to x now, not y. I expect you to have this. If you're interested in the summation of all of the y's, so if you sum all of the y's together, I expect you to have this. You can keep going on and on.